Hello children, I am Bindu. Today I am going to teach you the chapter Sound of Physical Science of Grade 8. This is the first part of the sound. After the completion of this lesson, students will be able to understand the production of sound, explain the propagation of sound in a medium, definition of wavelength and its unit, definition of frequency and its unit, numerical related to wavelength and frequency, factors on which the propagation of sound depends. Keywords to remember: propagation, wavelength, frequency, hertz, humidity. This is the mind map of sound. We hear a variety of sounds in our daily life. The thundering of clouds, chirruping of birds, meowing of cats, ringing bells, music on the radio, and the noise of vehicles are some of the sounds that all of us are familiar with. Each sound has particular characteristics. Sound enables us to communicate with each other. Animals also communicate with other members of their species with the help of sound. Some sounds like music are pleasing to us and we like to hear them. But some sounds, for example, noise in our surrounding is undesired. A metal plate is taken or a pan. Hang it at a convenient place in such a way that it does not touch any wall. Now strike it with a stick. You can see that it is vibrating. Sound is produced when an object is set to vibrate. Vibration means a kind of rapid to and fro motion of a particle. This to and fro motion of the particle causes the substances around it to vibrate. Thus, sound spreads to the surroundings. Sound cannot move without any medium. By the way, what is a medium? The substance through which sound is transmitted is called the medium. A medium can be solid, liquid, or gas. Sound moves through a medium from the point of generation to the listener. We can understand the production of sound with the help of some activities. A bell jar and a mobile phone are taken. Switch on the music on the mobile phone and place it in the jar. Now, pump out the air from the bell jar using a vacuum pump. As more and more air removed from the jar, the sound from the mobile phone becomes feebler and finally very faint. It is clear from this experiment that sound cannot travel in a vacuum and it needs a medium like air. Sound travels in water and solids also. The speed of sound is more in solids than in liquids, and it is very less in gases. Thomas Alva Edison in 1877 invented the phonograph, a device that played recorded sound. Wavelength is the distance between two consecutive particles which are in the same phase of vibration. It is denoted by the Greek letter lambda. The unit of wavelength is meter. Frequency is the number of vibrations of a particle in the medium in 1 second. It is denoted by N. The unit of frequency is hertz. The speed of sound is the distance travelled by sound in 1 second. It is denoted by V. It is represented by the expression V is equal to N lambda, where N is the frequency and lambda is the wavelength. Let's do a problem related to that. The problem is, a sound has a frequency of 50 Hz and a wavelength of 10 meters. What is the speed of the sound? The information given in the solution is frequency or N is equal to 50 Hertz. Wavelength or lambda is equal to 10 meters. We have to find out the speed of the sound. So, in the place of N, we shall put 50 and in lambda 10. If we multiply them together, we shall get the speed of sound, which is 500 meter per second. V is equal to N lambda. V is equal to 50 into 10. V is equal to 500 meter per second. Now, we shall solve another problem, which is a sound has a frequency of 5 Hertz and a speed of 25 meter per second. What is the wavelength of the sound? The information given in the solution is frequency or N is equal to 5 Hertz, speed or V is equal to 25 meter per second. We have to find out the wavelength or lambda of the sound. So, in the place of N, we shall put 5 and in V, 25. If we divide 25 by 5, we shall get the wavelength or lambda of the sound, which is 5 meters. V is equal to N lambda. Lambda is equal to V by N is equal to 25 by 5 is equal to 5 meters. The speed of sound depends on the properties of the medium through which it travels, like temperature, pressure, and humidity. In any medium, as the temperature increases, the speed of sound also increases. For example, the speed of sound in air is 331 meter per second at 0 degrees Celsius and 344 meter per second at 22 degrees Celsius. The amount of water vapor present in the air is known as humidity. It is less during winter and more during summer. The speed of sound increases with an increase in humidity. This is because the density of air decreases with an increase in humidity. We saw that sound travels in different mediums with different speeds. Now, let us see how it travels in a medium. When a body vibrates, the particle of the medium in contact with the vibrating body is the first displaced from its equilibrium position. It then exerts a force on the adjacent particle. This process continues in the medium till the sound reaches the ear of a person. To understand this, let us consider a vibrating tuning fork. When a vibrating tuning fork moves forward, it pushes and compresses the air in front of it, creating a region of high pressure. This region is called compression. When it moves backward, it creates a region of low pressure called rarefaction. These compressions and rarefactions produce the sound wave, which propagates through the medium. Summary of the lesson. Sound propagates through medium, and the medium can be solid, liquid, or gas. Sound is produced by the vibration of the particles of a medium. A sound is a form of energy that is transferred as vibrations through the air or any other medium in the forms of waves. The distance between two consecutive particles which are in the same phase of vibration is called wavelength. Frequency is the number of vibrations of a particle in the medium in 1 second. The speed of sound is the distance travelled by sound in 1 second. The speed of sound depends on the properties of the medium through which it travels, like temperature, pressure, and humidity. Sound cannot propagate through a vacuum.